objects, and you just want to kind of categorize them. You want to have the messages related to this functionality, different messages related to this functionality. You can put them in distinct categories. You can put them in distinct files. Different people can work on different subsets of functionality for a class. So they're useful in that regard. Somewhat similar in spirit to JavaScript and the prototype property, whereby you can add functionality to existing objects via a somewhat similar mechanism. All right, and we'll also see them in the context, sort of a clever trick that folks have adopted. We'll also see them as a means of implementing effectively private members, private methods, or instance variables to a class that you don't want the rest of the world to know about by putting them in your .h file. But we'll see that by example. Yeah?
What's the design guideline? Do you put functionality in categories, or do you put them into their own classes?
Good question. So what guideline do we decide where to put our method declarations? For instance, why might we put Baz inside of a category as opposed to somewhere else? So a couple of reasons, just to recap. One might be if I am the guy implementing the bar category of methods, I just have chosen for development convenience to put them all in one file, therefore all in one category, so that I can kind of mesh nicely with colleagues who are implementing other categories of methods. So it's just programmatic convenience. But we'll also see instances where if you want to have instance methods associated with a class, but you want them effectively to be private, not broadcasted or advertised to the world, you don't want to put them, therefore, in your .h file, because then anyone poking around at your library would see them by nature of what a header file is meant to be. It's meant to be included by other people or imported by other people. So you can tuck them away and still document them and still teach the compiler that they exist, which is helpful for you using Xcode since it knows more about your code. But you're not advertising them to the rest of the world. It doesn't make them truly private, because you can still send any message to any object that you want, and just on a whim, hoping that it exists. And if it exists, it will be responded to. But it's a mechanism to approximate that idea of privacy. It's just not strictly enforced. So I would keep those two guidelines in mind. And lastly, protocols. This is a more complex manifestation of this than we'll see later today. But a protocol lets us do what in Objective-C? Yeah?
Find a set of methods that should be implemented by the class that implements the protocol.
Exactly. It allows us to define a set of methods that should be implemented by some class that adheres to that protocol. So if you're familiar with Java, it's effectively an interface. And other languages have the same conventions. It is a set of methods that you, a class, promise to implement if you declare yourself as adhering to that protocol. And there are ways of specifying that the methods are optional, but by default, they would typically be required. And the compiler will yell at you if you say, I'm implementing the NS copying protocol, but you, the programmer, forget to actually get around to implementing the required methods to make that possible. All right. So the biggest takeaways from this recap, I would say, are 1, what a pointer is. 2, what an object is. And I think those two would make me pretty happy moving forward. So just to recap, an object is an instantiation or an instance of a class. A pointer is? It's an address of some piece of data, and that will often be the address of some object. So if you're comfortable with those two definitions, I think we can get through this. All right, so iOS. So iOS adheres to a design paradigm, generally known as MVC, which stands for, as you might guess, Model View Controller. So we're not really going to spend any time on the M today, but we will spend time on the C and the V, the controller and the view. And you can think of the controller of a program that adheres to this MVC paradigm as really being the brains of your program. It's where you probably spend much of your time implementing your program's logic, responding to user interactions, displaying things on the screen. But with that last goal, displaying things on the screen, all you do is tell someone else to actually do the rendering of information on the screen. So if I'm a program, for instance, whose purpose in life is to display someone's account balance in their bank account, I, being the controller, would respond to the user's username and password. I might somehow check that their username and password are correct when they log into the bank's website. And then I, the controller, upon realizing, OK, this is user David, I'm going to go check his bank account And I'm going to check that by asking someone called the model, but more on that in the future. Once I have that value, like $100, I'm then going to hand that value, 100.00, to something called a view to actually present that information to the user. So in other words, data is typically stored in the model. In this case, that's where my financial numbers might be stored. The controller is going to be the brains. All of the code that you write to sort of respond to ifs and elses and for loops and while loops will often be inside of your controller. And then when it comes time to display the results of all that number crunching to the user, you typically hand the data that you have gathered or computed off to something called the view. And the view takes it that last mile. It's sort of the HTML and the CSS of the world of the web. In the context of iOS, it's going to have to do with what the user sees on the glass screen. So this is a paradigm that you should keep in mind, because at many junctures, particularly with the iOS project, the staff's choice, you'll have to decide for yourself, where do I put this variable? Where do I store this data? Where do I actually display something on the screen? And the goal with adhering to a design paradigm like MVC is to not blur these lines and to adhere to these best practices so that when you start collaborating with someone else, or when some new device comes out, like the newest iPad, which is maybe bigger than the 2 existing iPads, you don't have to change how you're representing your data. You don't have to change any of your so-called business logic, the guts of your program. All you have to do is change or add a new view. And this makes it super easy to deal with things like iPhones and Windows phones and Android devices and all of the different displays or views that a user might interact with. You don't have to touch the essence of your program. And that just makes life much, much easier as your programs get more complex and more interesting. All right, so here is now, how an iPhone application or an iPad application works in more detail than we need for today. But let me go ahead and zoom in on a portion of this. The key feature of this picture is the fact that there's that circle in the bottom left-hand corner, generally known as an event loop. And as you might imagine, if you have an iPhone or an Android device or anything that's a touch screen these days, for the most part, it's just sitting there for the entirety of its life, waiting for you to do something or waiting for something external to happen, like an SMS message coming in or a phone call coming in. So it makes sense that the essence of a smartphone or a tablet these days is just to sit in an infinite loop, waiting for something to happen. And that's indeed what's really happening in some form underneath the hood. So this is a picture from Apple's documentation, the URL for which is at the bottom of the slide, if you'd like to read the whole article. And when you launch an application, you tap an icon. The main function gets invoked, which just like in the world of C and Objective-C, independent of iOS, is the first function that gets called. We'll see that there's typically a function called UI application main that's called by default, by convention, just because Apple designed the infrastructure to run that way. And then we load the main UI file, UI being just user interface, so something having to do with the visual aspects of my program. First initialization, whatever that means. Maybe it's loading some of my top scores if it's a game, or maybe it's loading my bank account information from cache, something like that, some piece of data. And now we have a fork in the road. Well, let's see, let's just go straight down and assume that I haven't written any code yet. We're going to restore the UI state. So if I, for instance, played this game 5 minutes ago, but then had to take a call, maybe I need to redisplay to the user where they paused the game rather than starting from scratch. So that's what we mean by restore UI state. Initialization, whatever that means for my particular program. And then once we reach this blue rectangle, we've activated the app and just start listening for the user to touch the screen, for a monster to come by on the screen, for a phone call to come in, for an SMS to arrive. We just keep waiting for something interesting to happen. Meanwhile, stuff can happen. And this line going from left to right is pointing at this box that says handle events, where an event is any of the things I just described. Something external triggered by the user or external triggered by the network to which you're connected. Now, meanwhile, we have some slightly more technical detail on the right. This is the last portion of this picture. On the right, everything in this big white box is my code that I've written. So we see in a monospaced font some functions or methods that we'll soon see in some actual code. And for instance, one of the functions up there is called application will finish launching with options. This is a common characteristic of Objective-C methods. They are atrociously long named, but they're very descriptive. And they capture their names describe what their arguments or parameters are. Various methods, which is a nice hand wave there. Application did finish launching with options. So notice the difference. first one is will finish, so it's about to finish launching. Did finish means it's after the fact. So if your code needs to do something before or after that change in state, you have that control. And then lastly down here, application did become active. So if you have ever implemented a game, this kind of implies that you can, for instance, immediately resume the game because somehow or other Apple is providing you with these hooks into interesting key events. This is quite like we saw in JavaScript with the world of DOM. On click, on submit, all of the interesting things that can happen in JavaScript can happen in similar spirit in the world of iOS. So this white box is what we're going to start writing today, and Apple has written all of this stuff for us and essentially just allows us to hook into this event loop, waiting and listening for interesting things to happen, just like JavaScript and jQuery allow us to do quite readily in the world of HTML. Yeah?
Event will say a tap on the button. Will the event affect for that run in its own thread? Or will it effectively block the event loop?
Good question. Short answer is it depends on what kind of action is and where it happens. For instance, if you have a program that's running and you get a phone call, Apple's threads can take higher priority and therefore interrupt your program and actually show you on the screen who is actually calling. So multi-threaded, yes, but not necessarily in the sense that you can't continue running while that phone call is in progress. So there are certain design paradigms that Apple adheres to that forces your threads to go to sleep when more important things happen. And this is in contrast to the world of, say, Android, which lets you do a lot more. And the argument long-standing for Apple has been that this way they can police battery life better so that you don't have some thread in the background just churning and churning away. But the price we pay is that if you run, for instance, the Gmail app on your phone, you can get notifications and be informed that you have new mail with the little badge number being incremented. But if you want to actually check your mail, you have to load Gmail, refresh the screen, wait a few seconds, and then see your email. And I bring this up as an example because it drives me nuts. Whereas the built-in mail application has is more tightly coupled with the operating system and can actually do all of that in the background in its own thread. All right. So UIKit is where we begin our look today. And UIKit is just the user interface related SDK that Apple provides to the world, software development kit. So these are some class names that will quickly become familiar to us, some more so than others. And they describe different classes that allow us to do different things. UI application is the class that describes an iOS application. UI application delegate is similar in spirit, and we'll come back to delegation and protocols later today. UI view describes the aesthetics of a program. It's a class that represents something that's on the screen. Maybe it's a rectangle, maybe it's a button, maybe it's a text field, so something like that. UI view controller is unfortunately named. Apple calls controllers view controllers. So they are distinct. View controller is the C, UI view is the V. View controller is, again, just a C, not a V. It's the brains of our application typically. And UI window is just a class that represents the rectangular piece of glass in some form that your application is going to run inside. So let's go ahead and write our first application. It turns out we have different starting points that Xcode provides us with. We don't really have to use any template code that Apple provides, but you'll typically find that it's a great way to get started quickly, even if you just start with an empty application. So let's do this. Let's see if we start by loading Xcode here and going up to the File menu and going to New Project. So not New File, but New Project. So I get a whole bunch of folders and a whole bunch of files for free. Notice that we've got some organization here. And last week, you may recall poking around with OS X because we just needed some simple Objective-C programs, not necessarily iOS. Tonight and hereafter, we focus only on the top half of that menu under iOS, where we have an application category, framework and library, and other. Most everything we'll be interested in for now will be under iOS application. So here are those same template names we saw a moment ago. And if you're familiar with an iOS device, you probably recognize some of the design paradigms here. The master detail view looks like it has a little menu on the left-hand side and then more information on the right-hand side, like the built-in mail application. OpenGL game refers to a graphics-based game. Page-based application means something that has that sexy page curl that happens from the bottom up. Single view application is a place we'll spend some time today since it just allows us to have some basic sample code and to get started quickly with a user interface of our own. Utility application, which is something like the weather or the stock application. Super simple, but typically have a button that allows you to flip it around to see some settings. And indeed,